Hello, this is student ID G00116209, and this is a video presentation of my mail package delivery theft deterrent prototype system, and just a short description of what this system does. Whenever this distance sensor will detect a package that's delivered in front of the porch of the residence unit, and whenever somebody that's unauthorized removes the mail package, the system is designed to go into alarm. If the system is uh, currently in the arm state, as well as if the, the the code that's inputted on the outside of the unit doesn't match the program code that's set by the resident. Um, so this is my microprocessor, the Arduino microcontroller, I should say, and it's obviously using the ADMIG microprocessor, which I currently have it programmed to convert my analog input that's coming from the distance sensor to a digital signal, so I can process that data, as well as I calibrated the distance sensor to approximately detect a package around about 8 inches away from the distance sensor. So this will give them the delivery drivers, so that they don't have to put it right on top of the distance sensor. So that's already been pre-programmed and shown on a previous video. So right now, all my previous videos showed the individual circuits as they were hooked up. They showed my hold on a second. It showed my distance sensor detection circuit, and once again, that's using the microprocessor. Whenever a package is delivered, it will provide 5 volts DC to the output of that circuit, and as you remember, that green LED will light up, indicating that a package is detected by the distance sensor. I also have my comparative comparison circuit. This is my comparison IC chip, and what that does is it's going to compare the input, my program dip switches, which I'll bring my video a little bit closer. These dip switches here right now, they're currently all set on high, or 1111. That will be inside the residence unit, so the resident can actually set a code to whatever the code. This code will need to match the code that's on the outside of the apartment, and this code is currently set on I believe 1111 as well, or high. So that will be on the outside of the unit, and that will be used by the delivery. Sorry, that will be used by the person outside the unit to enter the code to safely remove the package without it going into alarm. So my comparison circuit basically is going to compare those two inputs from, once again, the dip switches on the outside of the unit with the dip switches that's programmed inside the unit by the residents. If those two codes match, going to my comparator circuit, the output, which I believe is pin 6 of the IC chip, will present a high voltage if the two codes match. Otherwise, it's going to provide a low, indicating that the two codes do not match. So So that's my comparator circuit, which I explained on a different video when it was hooked up by itself, and gave a presentation of how that circuit actually worked, and it actually did provide a high voltage whenever the two dip switches match, and when they didn't match, it provided a low. My other circuit is my arm disarm latching circuit, and that will be these push buttons here. This push button is my disarm button, and that once again is also inside the unit, used by the resident to disarm the system, so that they can go outside and remove the package. This push button right here is my arm button, and that will be on the outside of the unit, and that's used by the delivery driver. So when the delivery driver places a package near the distance sensor, they go ahead and press that push button to arm the system. And then these LEDs right here, green indicating that the system is disarmed, and then the red I want to arm it. Press the arm button so the delivery driver arms the system. Then if I was to disarm it, I just press this button in the inside unit to disarm the system. And that's my arm disarm latching circuit, which is feed into the NOR gate, which is one of these IC chips over here. This one and this one. Well, this is my NOR gate, and then this is my it's basically a NAND gate. It's using the not using inverters in there. Basically using the NAND gate as an inverter. So that's my arm disarm latching circuit. And then I also have my alarm interface circuit, and that's with the 3 input AND gate. And that's going to take the output of my comparator circuit, which is here, my arm disarm latching circuit, which is over here in this IC chip, the NOR gate. And then it's also going to take the output of my distance detection circuit, which is over here. That green LED indicates whenever the light is on, indicates a package is present. So all those 3 outputs for the arm disarm latching circuit, the comparison circuit, and the alarm, and the distance sensor detection circuit are all fed into my 3 input AND gate, which is over here, and that's the alarm interface circuit. So when all 3 of those inputs provide a high to that AND gate, its output will generate a high that then feeds the output audible circuit. So once again, and that red LED is my alarm. Whenever the light turns on, that indicates a high, or approximately 5 volts DC is present to feed into my output audible alarm circuit. So right now, as you can see, it's off because it's not an alarm. And the last circuit, which I just kind of touched on, was my output circuit to the audible sounder. And that's actually all the way over here, these resistors and that transistor, that switching transistor, right there. And then this right here is my audible sounder, which has a volume adjust, which currently I have it on really low, so don't disturb anybody. and those dip switch settings basically just set the tone. Currently, I'm using maximum 107 dB if I turn up the volume all the way to max um, to meet some of the requirements similar to the fire alarm NFPA requirements for an audible system. But once again, I do have my volume adjustment kind of turned down, so like I said, it doesn't really disturb anybody. So once again, my alarm interface circuit from the NAND gate, this IC chip over here, its output is fed into my transistor, the base over here. So whenever a high is generated or an alarm condition is present, or an output is sent from the AND gate, the alarm interface circuit is fed into that transistor. That transistor will then switch the transistor to on, and since the transistor is pretty much isolating the two voltages, my 9 volts DC that's powering my microprocessor, as well as providing the 5 volts DCC for my digital circuits. And then the other voltage is the 24 volts DC that's used for the sounder to generate enough power to power that 107 decibel sounder, which I can actually use a strobe as well for visually impaired to kind of meet ADA requirements. So as you can see right now, the system is disarmed with that green LED, and the system is not an alarm. So I'm kind of just going to simulate how it works. So right now, I'm going to pretend that I'm a delivery driver, and with the system disarmed, I'm going to put a package approximately 8 inches away from the sensor, from the distance sensor. So, and I don't know if you saw that, but notice when I put the package near the distance sensor, this LED lit, so it's detecting a package. Now, and get a pen real quick. Right now my dip switches kind of match, but I'm going to change this dip switch setting to off. So now they do not match because I'm going to simulate an alarm condition. So right now they don't match. Right now the input, the resident set up all the dip switches high, so that it's a 1111. And my output code is set as 1110. As you can see that. And then, so let me start over. Now the package mail delivery driver puts the package near the distance sensor, approximately 8 inches away. The package detection light lights up, and what they're also going to do is the delivery driver will press the arm button, and now the system is armed. So now, in order to remove this package from the front porch, either a valid code needs to be entered, or the system needs to be disarmed on the inside of the unit. So I'm going to pretend that I'm a burglar, and or an unauthorized person, and remove the package. As you can hear, the system goes into alarm because they just removed it. The alarm LED is on, and basically it's doing what it's supposed to do. So I'm going to disarm it. I disarm it, the sound silences, and now I'm going to redo the whole sequence, but I'm going to be act like an authorized person to remove the package. So once again, the system is disarmed, and I'm going to place my package near the distance sensor. You can see it's about 8 inches away, so pretty good distance there. And LED lit up, indicating the package has been detected. And now, once again, I'm the delivery driver, so I'm going to arm the system. System is armed, and now it's going to once again require either the correct code to be inputted, or the system needs to be disarmed inside the unit. So in this case, I'm going to pretend I'm going to input the correct code outside the unit. So if you remember, all the dip switches need to be a high. So for the correct code, so I'm going to set this dip switch on. So now it's a high. So now I should be able to remove the package in the arm state without tripping the alarm. So that's what I'm going to do. I remove the package, and you notice the LED went out, the package detected, the siren is not sounding. As you can see, the alarm LED did not light. So I safely removed the package because I put in the correct code. So then now once I'm inside the unit, I could just go ahead and disarm it. And the system is disarmed. So my last test is to pretty much just be able to remove the package while the system is armed inside the unit. And so with the system disarmed, um, in this case, I'm once again going to change the code on the outside of the unit. Okay, once again, I did put in 0001, and I could just put for demonstration purpose, I'll put a completely different code. Put 01. Sorry, I did 1011. So once again, the code doesn't matter. The system is disarmed. You can tell by the LED. And now I'm once again acting as a delivery driver. It's my package. It's been about 8 inches of the distance sensor. The green LED lit indicating the package has been detected. And once again, the delivery driver presses the arm button and the system is on. So now it's going to either once again, a correct code needs to be inputted on the outside of the unit, or the system needs to be disarmed inside the unit to remove the package. So in this particular case, I'm just going to act like I'm inside the unit, leave the code to whatever is outside the unit, so I don't have to actually go outside and input a code. So I'll just go ahead and disarm the system. I'll do this so you can actually see the LEDs change. System is disarmed, and then I should be able to remove the package without the system going into alarm. You see the green LED went out, the package is no longer detected, and the red LED did not light up, that indicating alarm condition, as well as you didn't hear the siren sound. So the system is working as it should, and that will complete this prototype simulation of the mail package delivery theft deterrent system. Thank you for watching.